Thank you for joining us today. So today we'll be speaking about achieving zero energy, advanced energy design guides for multifamily buildings. A little bit of an outline of what we'll be speaking about today. We're going to start off with talking a little bit about ASHRAE, the Advanced Energy Design Guide history. John Michael then is going to speak about the Advanced Energy Design Guide for multifamily buildings. And then we'll follow up by talking about some of ASHRAE's current and future efforts related to decarbonization. So ASHRAE, if you didn't know, was formed over 100 years ago, and its mission is to serve humanity by advancing the arts and sciences of heating, ventilation, air conditioning, refrigeration, and their allied fields. So the vision for ASHRAE is related to a healthy and sustainable environment for all. And a lot of you may know about ASHRAE because of the various standards and guides related to energy and indoor air quality, building energy efficiency, and thermal comfort. The local chapter here now, it's been around for over 50 years. As mentioned, we have our chapter meeting here coming up next week. And there's monthly meetings that ASHRAE has from September through till May. We have several other events, social events, such as our holiday social that'll be coming up in December. We have our golf tournament in June. There's volunteer events related to sustainability. We've volunteered for Feed Nova Scotia and Habitat for Humanity. There's a local student presence within Dalhousie, and we raise money for ASHRAE research that happens in Canada. So a little bit of a history here on the Advanced Energy Design Guides. Like some of you may know, the Advanced Energy Design Guides have been around for quite a while now. The first series of guides, which were related to 30% energy savings, came out 15 to 20 years ago. So I remember using some of those to look at some designs several years ago. Then around 10 years ago, they released a new series of guides related to how to achieve 50% energy savings. They moved the benchmark to ASHRAE 90.1 2004 at that time. And over the last 5 years, they've moved on to zero energy design guides. So we're going to be talking about one of those today. So as a little bit of a history here to expand upon the different guides. The first series of guides for 30% savings, and one thing I should say is these guides are all available for free on the ASHRAE website, so you can download the PDFs. If you want the hard copies, you can order them. You pay for the hard copies to be delivered. But the first series of guides for 30% savings were on mostly small buildings, small office, small hospital, small retail. I think they felt that was the buildings that needed the most, that people could use the most advice on, because usually you didn't have a design team doing energy modeling and everything on those small buildings. Whenever they got to 50, whenever they decided to do the next round in 50% savings, they looked at more medium, larger size buildings, hospitals, and big box retail. In the zero energy guides that have come out in the past 5 years now, they've looked at small and like office buildings and schools as well, but there'll be the multifamily buildings as well. Oh, that's actually, the multifamily buildings that has come out as well. One thing I should say is what we have here is there's a whole new approach with the zero energy guides that we'll be focusing on our discussion on today. So if you remember looking at the older advanced energy design guides for 30 and 50% savings, they were based on a prescriptive approach. So kind of like looking at the energy code, there's a prescriptive path and there's a performance path. With the 30 and 50% guides, there was basically just a prescriptive path. So it was a series of tables where you could look at, they would say like, use like R40 roof, do R20 walls, do condensing boiler. They would tell you prescriptively what you could use to design your building to achieve the 30 or 50% savings. The net zero or zero energy guides are totally different, and they don't have these tables anymore. They focus on a process, and they want you to do energy savings and set your goal for energy savings and then size your renewable energy system. So there's a whole new approach. So with this whole new approach, John Michael's just going to take over to talk about the guide.
So the guide has 5 main chapters that we look at. Introduction kind of covers some of the past guides, 30-50%, how they change going into this guide. They talk about some of the principles, then the process for success, which is really the bulk of the guide, and then they talk about some analysis that you can do post-building, and then some how-to strategies, which really are like a lot of meat to, you know, if you have different outcomes for this buildings. So the U.S. Department of Energy defines zero energy as an energy efficient building where on a source energy basis, the actual annual delivered energy is less than or equal to the on-site renewable energy. So the picture below just shows on the left a building with some solar panels and the source energy on the right, and how the meter kind of peters out at zero, hopefully that you get your renewable energy. So site energy is your meter that, you know, Nova Scotia Power or any other power company has at your home or building, and then your source energy comes from the power plants, the transmission lines to the building. So usually the site energy is approximately a third of the source energy, so you need about 3 times the source energy to get to the site. That also factors in, you know, fuel to transport the coal to the power plant, or you know, transmission loss through the power lines. And this will change as the grid evolves over time. We're hoping for maybe like a half or 50% efficiency. So some other reasons you want to pursue zero energy is, you know, your reduction in utility costs. That's the big one that was talked about in the previous presentation. Improve marketing potential and reduce vacancy rates. So people in zero energy buildings are more likely to stay because they want to have cheaper energy bills and they enjoy, you know, helping the planet. Increase affordability of units. If your building itself is operating at a cheaper cost, you don't have to charge as much for your units because you don't have much of an overall heating cost with some included buildings. Your increased resiliency, so if the power goes out, if the building's more efficient, the heat will stay inside. Mitigating the impact of climate change, which is a really big focus now on carbon reductions and emissions. And then also, as we saw with the NECB 2020, the code requirements, which are coming soon. So with the principles for success, it talks about developing the culture and mindset. So you want to have a team that focuses on achieving zero energy, and the owner itself also wants to have zero energy. You have to identify a champion. So the champion is the person who's in charge of driving the bus, making sure the architects, engineers, and owner are all aware of the zero energy process, how to get to there. They're in charge of, you know, leading the meetings. And then you want to collaborate and iterate, so that's also getting together a lot, looking at maybe even past projects, how you can improve some issues you might have encountered. And then you want to adapt to future needs, which is your technology, resiliency, grid alignment, and you want to also account for retrofits, which can be a large expense with building these buildings. So in the process for success, it defines 6 steps you want to take. Your first is setting the goal, and then you want to establish a financial model. Your third is you select a project delivery method. So the traditional is the design, bid, build method. You then want to incorporate the goal in the project requirements, and then you want to hire the team. Usually the hiring the team does happen around the time that you set the goal, so you can do it in this order, or the traditional order might be you have the team and then you design the financial model. And then you also want to confirm and verify after the building is built. You know, you do your tests, you do your pressurized testing to make sure that the building is meeting that zero energy standard. So there is some critical roadblocks where the zero energy buildings tend to fall off. The first one is the request for proposal. So they see that the cost might be higher for designing a zero energy building. Then with their first estimate, they realize, well, we have to do higher efficiency HRVs, we have to do better efficiency air handler units, and it can tend to be a bit more pricey. Then with value engineering, you know, you tend to lose a lot there, where they start to fall off with other choices for, you know, maybe supply chain issues or other units that you might consider. And then during construction, you can also run into activities where longer construction periods, maybe you have a delay, and usually you then make it to the successful zero energy project, but it's a long road. So you want to determine your EUI first. In Atlantic Canada, we have 70 to 75 kilowatt hours per meter squared per year of EUI. We're in the 6A and 7 zone, and 5A, kind of three that we look at in Atlantic Canada. So you want to incorporate the goal in the project requirements. So the owner's project requirements, which is the owner gives what he wants, what they want the building to be. Zero energy, they want so many units, so many square feet. And then the team takes that and they build a basis of design that they then submit back to the owner. So how they're going to meet those requirements, the owner is then given them. And then the next process is confirm and verify. So you're updating the energy model throughout. When you just finally select your systems, you're putting in the actual COPs, you're putting in the design temperatures, you're going space by space and putting in, what the usage might be in that actual apartment. And you're looking at all your systems and making sure they are reaching the efficiencies that they claim on the data sheet. And a big part is educating the building occupants. The building cannot be zero energy if the occupants are not aware the building's going to be zero energy. So it could be through lighting, could be through motion sensors, could be through reminders or floor-by-floor challenges is a big thing that they put. And then you also have to verify and track that the energy use for that building is like aligning with the zero energy target that you set at the start of the project. I'm going to hand it back to Aaron to talk about the rest of the presentation.
So as I mentioned, there's no prescriptive path for this guide, so they want you to perform analysis. So what you would, they have a whole chapter on leveraging analysis to drive design. So for example, in the concept phase, usually your building form isn't chosen, so you might start out at the concept phase of looking at different different masses of buildings. It may be, do you want your building to be 2 stories, 3 stories, 4 stories? Do you want it to be orientated on an east-west axis? You can look at all these different forms and then see how that impacts your ability to install renewable energy to make your building zero energy. One thing I should mention is the guide refers to another standard, ASHRAE standard 209, which is an energy modeling for building design. So this standard provides advice in terms of what energy modeling could you be doing at different stages of the design process. So this is basically just mimicking that. Whenever you get into schematic design, the next stage of design, typically your building form is chosen. At this stage, you can look at levels of like R value, your thermal resistance of your wall, shading strategies inside or outside your building, and you might start to look at some of the mechanical systems. Whenever you get into design development, usually at that point in time, so you've reduced your heating and cooling loads by installing or designing a good building envelope, so then you can start choosing your mechanical systems. You don't want to look at your mechanical systems first before you reduce your heat loss and heat gain. So after that, then the design development is really the time where a lot of projects select their mechanical systems. So that's where you can start to evaluate different systems. Then whenever you get into construction documents, usually at that point in time, the energy modeler can start to put in actual design information into the energy model. So before this, there's usually a lot of assumptions, like you don't know the actual lighting power density, the actual fan powers or pumping powers. Whenever you get into construction documents, you want to put in the actual sizes of equipment, the actual capacities, the actual powers for fans and pumps, and using some more accurate operating schedules so you can get a better idea to confirm that your building is still on track. Then, of course, the building gets into construction and there's change orders and revisions, so it's a good idea that any major changes that happen during construction, that those are incorporated into the energy model so that you see, like, are you still on track for your net zero goal? And then the building's complete, you're working, the building is starting to be occupied. You want to look at calibrating the energy model, and then to see, like, are all the systems operating properly. So that will help you verify by almost like a digital twin in a way, looking at the actual building energy use compared to the energy model, and trying to identify what issues there might be with the operation of the building, if there are any. So the last chapter of the book is a very lengthy chapter and has a lot of helpful information on how to design related to building envelopes, to lighting and mechanical systems, renewable energy. So you can see lots of details like we see on the screen here around, like, for example, parapet insulation, how to design air-to-water heat pump systems. There's a lot of information related to more of the current issues that are going on with the current design, to reduce some of the energy use to really make net zero buildings, some things that we didn't really think about maybe 5, 10, 20 years ago. So I'm just going to talk a little bit about a case study from the energy guide. So this building here wasn't actually a zero energy building. There isn't, as you may know, this guide was written I think it came out last year, but a lot of it would have been written a couple of years ago, and there isn't a whole lot of net zero or zero energy multifamily buildings around. So, but this building is down in New York State, on the Atlantic Ocean, 8-story, 127 unit apartment building. They installed a ground source heat pump system with high efficiency ERVs and solar PV. Their EUI was 33 kilobTUs per square foot, which is just over 100 kilowatt hours per meter squared. So it's above the guide's recommended EUI. They didn't put in enough renewables to get to net zero, so about like 10-15% of their energy use is offset with renewables. But I don't know if that building had net zero as or zero energy as a goal at the beginning, but they did achieve FEIS, which is passive host certification. So that's quite a goal for air tightness and everything. So now I'm just going to move on and talk a little bit about ASHRAE's latest efforts. So ASHRAE, a couple of years ago, realizing that the industry in general is shifting its focus from energy savings to carbon savings. So ASHRAE developed a task force, the Task Force for Building Decarbonization. So ASHRAE also put together its own position that by 2030, the global built environment must halve its 2015 greenhouse gas emissions, whereby all new buildings are net zero greenhouse gas emissions in operation. There's widespread energy efficiency retrofits of existing buildings, and embodied carbon is reduced by at least 40%. So those are kind of a lot of key pieces of information and things I think that are becoming more widespread. I think in our industry in the last couple of years, we're starting to hear a lot more about these similar strategies. So I think it's a good goal to adopt. So this task force, they've been working recently on 7 different guidebooks, and I think they're all related to very important and pertinent information recently. So the first one that was already published is related to grid interactive buildings, and there was also the second one was around building performance standards, which would be performance standards for like basically energy use of existing buildings and how to adopt those into legislation. The next one that will be coming out is around heat pump design. So there's a lot of talk and a lot of people are working on heat pump design and how to apply that to buildings. The next couple of guides are around carbon and the life cycle embodied carbon in buildings. And the last 2 guides that they're working on are related to decarbonizing hospital buildings, which is a big challenge with healthcare facilities. They oftentimes use like fossil fuel boilers to create high temperature hot water and steam and to try to decarbonize those facilities. And as well, there's a lot of need in retrofits. We know that most of the buildings that are going to exist in 2050 are already built today, so we need to retrofit these buildings. So they're coming out with guides for commercial and multifamily buildings next year. So that'll be really important to help decarbonize those facilities. So in conclusion, the multifamily guide offers a comprehensive roadmap to build and operate a net zero building or zero energy building with a focus on shifting to reducing carbon emissions. ASHRAE has providing new and updated solutions. We've come a long way to achieve. We have a long ways to achieve a sustainable future, and we thank you for your dedication and to being part of the solution. Thank you.
Thanks, guys. Any questions? Sure.
So the case study that you presented didn't meet the targets. So thanks. Are we expecting that ASHRAE will publish some case studies around buildings that actually do follow the guides? And the reason I ask is some of the things that are in that you presented, say haven't been necessarily proven in our climate zone, right? So specifically, that little diagram around the domestic hot water heat pumps, that we don't really have evidence of that yet, right? So having case studies from ASHRAE would be really helpful to help projects get beyond that. Well, I don't want to take the risk of this not working here. So is that part of kind of the follow through? Is some more like published case studies for folks to see?
Yeah, I
this
think.
works?
I think that ASHRAE won't be like republishing this guide with updated case studies, but what they do have is in their monthly ASHRAE journal. There's usually a few case studies in each journal, so I would say kind of keep your eye out for those and look for updated case studies. There have been some around net zero buildings. I don't necessarily remember any for zero energy multifamily buildings, but if you're aware of any, I think they would be happy to see them. So in terms of some strategies that may, I think he brought up like heat pumps, for example. So I think ASHRAE is aware of the fact that there's climatic issues or different strategies for different climates related to heat pumps. So I think that's why they're coming out with this new guide related to heat pumps and looking at some of the important strategies related to grid interactive buildings, because we'll be increasing our peak load. So how do we manage our peak load on our electricity grid as we electrify? And then looking at heat pumps, which are a big part of that. So I'm hoping that I think the new guide around converting the existing multifamily and commercial buildings to zero energy will perhaps have some more up-to-date information, because but yeah, it's not perfect. They don't have a whole lot of examples of net zero multifamily buildings.
Yeah, and I guess just thinking about how and not just the multifamily one, but all of the guides that ASHRAE publishes, I think it is more helpful and impactful when there's like a kind of concrete evidence of that working, right? Because the industry is really good at publishing guides, but the uptake sometimes is challenging.
For sure, yeah. Like what ASHRAE publishes along with each of these guides is what's called a technical support document, and these guides are all based on energy models. So then they have all the details of how they did their energy modeling to come up with the goals within the guide, or in the previous guides it was how did they come up with the recommendation tables, but now it's more so how did they come up with their EUI, energy use intensity recommendations to achieve net zero, and they talk about different like building heights. Obviously if you have a taller building, then you're going to have like a smaller roof area to floor area ratio. It's going to be harder to get net zero off your roof of your building, but it's something that I think ASHRAE is now kind of shifting focus now on. From what I kind of hear and read online, I think they're shifting focus from these net zero guides to more of the zero carbon guides. So I think I don't think they're necessarily going to develop more of these same zero energy ones, because they're going to shift focus to zero carbon guides, which are going to be a little bit different strategies, I think. But yeah.
question is for John Michael. You had a slide where you mentioned the site to source ratio of 3 to 1. In my mind, that's kind of an American lens on it. Can you share your thoughts on how it's relevant in Canada?
I think in Canada we definitely have a bit more issues with transmission loss, being a bigger country. The unfortunate part is that when ASHRAE is based in America, I would see we're more focused on putting more site EUI in, so we can put more solar panels and have less transmission loss. So that's where I think we would focus as a country. Overall is on like reduction in, like, you know, like we're putting an offshore wind turbine in, and Nova Scotia Power is at least or talk about the offshore wind turbine. So I think like putting more energy closer to bigger populations, and then you can worry about transmission loss maybe in more rural areas where like bigger areas might, like we should focus transmission loss on. Like a big city like Halifax or even Antigonish or Sydney would be the more key areas that we'd look at.
I can maybe pick up on that. I can maybe add a little bit to that. I think what you may be referring to is there's a lot of hydropower in Canada. So, for example, if you're not using combustion to generate your electricity, then your site-to-source ratio is going to be much different than if you're in a lot of the United States. They might use a lot more coal and natural gas to produce electricity. So you're going to have that 3 to 1 ratio because of your inefficient coal power plants. And if you're like looking at Quebec or Manitoba or BC where they have a lot of hydro, then your site-to-source ratio is going to be closer to 1 because you don't have those inefficient power plants generating your electricity. So, yeah, that guide was that thing was just an example of a jurisdiction. It's not something that they say to use everywhere across North America to use a 3 to 1 site-to-source ratio for electricity. You would use that for your particular area.
And we see it pop up in things like portfolio manager and things like that. But I think as the discussion evolves to GHGs, that kind of a ratio we won't have to talk about because it'll be all encompassing, right?
Yeah, I think that if you look at GHGs, then yeah, you're maybe a little bit less focused on source energy and more focused on emissions, and where you're, I think, as you go to like zero energy and if you go to as you go towards carbon, focus on carbon, then your source energy will be impacted there. You have to probably take a longer term outlook in terms of where's the grid going in the future in terms of, you know, how clean it might be. So you can't really focus too much on today, but for example, like if you electrify a building, it might have a higher source energy today, but a lower source, it's going to change into the future. So it's, I think it's, you probably have to have a little different focus, I think, when you look at decarbonization.
Thank you.
We definitely have a few more questions, and we're ahead of schedule, so if you do have questions, feel free to ask them.
Hey, Aaron.
Hey.
I was just wondering if you could comment on the how much calibration is required when calibrating the model to match actual performance.
Yeah, through my experience, like ASHRAE does have a guideline on calibration. I think it's guideline 14, talking about like recommendations for calibration, but yeah, normally there can be quite a few changes. Usually what I find the bigger impacts are related to operation, like the operating hours. So sometimes usually whenever you're doing your energy modeling, you're using standard energy code schedules of operation. Like it might be 10 hours a day for an office building, but in reality it might operate 12 or 14 hours a day, or it might be open on Saturdays. I find because that sort of thing impacts your lighting, your occupants, your air handling unit, like your mechanical systems operation. So I find that's one of the major things to adjust through a calibration. But you can also get into a lot of different things with calibrating related to the mechanical systems, whether it be like your water, hot water temperature supply resets and all these supply air temperature resets, all the different things you can get into with your mechanical systems. So it can be challenging. It just depends on how closely the building is actually used to the initial design, I guess. What changes were made through the commissioning process usually. Yeah.
Hello. Yeah. Hi. With Carmichael, and we just built a building in Belleville, which is net zero, and we're very excited about it. And one thing we learned is that it's been very difficult to cut through the clutter, and we coined our own term called operational net zero, and we're using that. And what I'm interested to know is, maybe now that we've done this and undergone the process, there's a lot of people within the company saying, very excited about it, some that are saying, hey, we'll never do that again because of what it costs. And just curious if that's something that's echoed with others in terms of once it's there, was it, did it meet expectations from that point of view?
Yeah, maybe I'll go back to the definition. So where the 30 and 50% guides focused on like design-based energy savings, the zero energy guides focus on actual energy use. You can see the Department of Energy's definition of a zero energy building as a building that actually has the annual delivered energy less than the renewable exported energy. So it's not focused on the your design theoretical energy model. It's based on the actual energy use. So this guide has a lot of focus on how to do your measurement and verification and your verification after the fact. So they don't consider one that was designed to be net zero to be a zero energy building. So I think it aligns with what you would say, what your definition is, I think. Yeah.
Any further questions? No? Okay. Well, thanks, guys.